Hello everyone, welcome back to Chemistry is Easy for You. Today we are going to do a topic which is very important for all the classes starting from class 12 to every entrance examination. So again, this is a very general chemistry topic which is asked for all kinds of exam, and we got very good response to the part 1 of this video. So here we are with the part 2 of environmental chemistry questions for all exams. The first question here is, which compound was the chief cause behind Minamata disease? So is it mercury 1 chloride or phenyl mercuric acetate, ethyl mercury or methyl mercury? So the answer here is option D, methyl mercury. And why the name Minamata disease? So this originated from the factory named Chiso Minamata factory, first started with acetaldehyde production in 1932. So this question can be asked in that way also. They can give the name of this factory or the year and then again ask for the chemical compound. So just be aware of all these general chemistry facts. It will be helpful for you in every stages of your life in whatever exam you are writing. Now the second question, an important secondary pollutant for photochemical smog is. So in these kinds of questions, the difficulty comes in identifying and differentiating between the options. So here nitric oxide, nitrogen oxide, ozone, and none of the above. The answer can be any of these because we know that all these are pollutants. So the key is knowing what are the primary pollutants and what are the secondary pollutants. So first of all, the answer here is ozone. Ozone is a secondary pollutant for photochemical smoke. Now let's see what are the primary pollutants. So the primary pollutants include nitrogen oxides, which are particularly nitric oxide NO or nitrogen dioxide NO2, and some other volatile organic compounds. And the secondary pollutant is ozone, and it is formed by the reaction of hydrocarbon and nitrogen oxide. It can be NOx, that is, it can be NO, NO2. So it is NOx, any of the nitrogen oxides. And this nitrogen oxides and the hydrocarbons combined in the presence of sunlight. So what is the definition of primary pollutants and secondary pollutants? We can identify it from here itself. So primary pollutants are directly emitted into the atmosphere and they cause photochemical smog or any of the pollution. But the secondary pollutants are directly not emitted into the atmosphere, but instead they will be formed by the reaction between many of the primary pollutants. So therefore, ozone, which is formed by hydrocarbon and the reaction between hydrocarbon and nitrogen oxide, becomes a secondary pollutant. So that is the answer for the second question. Now in the third question, we are asking that here given is a general chemistry reaction, and this reaction results in a product which is a powerful respiratory and eye irritant, and it is present in photochemical smoke. So what is the answer? Hydrocarbon, oxygen and nitrogen dioxide combines in the presence of light to form which of the following? So the answer is option C, PAN or peroxyacyl nitrates. So this is the general, the formula will be like this: CH3C triple NO2, and this can be also abbreviated as APN or PA, acyl peroxynitrates also. So in the previous question, we already learned about the definition of primary and secondary pollutants. In that line, we can say that PAN or the peroxyacyl nitrates are also secondary pollutants because they are not directly emitted, but instead formed by the reaction of hydrocarbons, oxygen and nitrogen dioxide, and then cause photochemical smog. Now to the fourth question. Sodium triphosphate, once a component of many detergents, was a major contributor to eutrophication, global warming, landslide, and acid rain. This is a very straightforward question, and the answer is eutrophication. So we know that what is eutrophication? It is the aging of the water bodies like ponds. This is known as eutrophication, and it is due to the over presence of a lot of minerals in the water body. Due to that, the aging of the water body takes place, and that process is known as eutrophication. And it is often induced by the discharge of nitrate or phosphate containing detergents, fertilizers, or sewage into an aquatic system. Most of the times this eutrophication occurs in such water bodies where people are washing their clothes, or it is near some farmland or sewage system. So sodium triphosphate contributes to eutrophication, which is the aging of the water bodies, and it occurs due to the discharge of nitrate or phosphate containing detergents, fertilizers, etc. The fifth question: which protocol was signed in 1987 and was the first step in the international efforts to protect stratospheric ozone? So this, everyone have heard of this. Everyone has heard of this protocol. It is the Montreal Protocol, and the Montreal Protocol, formally Montreal Protocol on substances that deplete the ozone layer. It is an international treaty adopted in Montreal on September 16, 1987. And the main aim of this protocol is to regulate the production and use of chemicals that contribute to the depletion of Earth's ozone layer. So there were many different steps and strategies that were formed as a part of the Montreal Protocol, and those were aimed into decrease the destruction of Earth's ozone layer. And so that's about the protocol. Now the sixth question: water supply with a BOD level of 3 to 5 ppm is considered moderately clean. So is that true or not? Actually, here actually I have already included the question in here. Sorry, this should have been omitted here. So the answer is 3 to 5 ppm. So the moderately clean level of water should have a BOD level of 3 to 5 ppm. Now what is BOD? A BOD indicates the amount of organic matter present in water. That is, it can be degraded. This organic matter can be degraded, and the biochemical oxygen demand, or BOD. A low BOD will be indicator of a good quality water. That is the very less presence of organic matters or the waste matters in the water. So if there is a high biochemical oxygen demand, or BOD, then it indicates that the water is polluted. Now let's take a look at the ranges. So a BOD level of 3 to 5 ppm is moderately clean. In water with a BOD level of 6 to 9 ppm, the water is considered somewhat polluted because there is organic matter present and the bacteria are decomposing this waste. So above 9 ppm, it is really polluted. So moderately clean level is BOD level of 3 to 5 ppm. The seventh question: which of the following is not a greenhouse gas? This question has been asked multiple times in many exams, and even when I was attempting one of the exam, I couldn't attend this question because I got confused between the options: water vapor, nitrous oxide, ozone, CO. For me, all these are greenhouse gases. It was very difficult for me to differentiate. So today I am easing your difficulty. The answer is option D, CO. The primary greenhouse gases in Earth's atmosphere are water vapor, carbon dioxide, methane, nitrous oxide, and ozone. Please keep these primary greenhouse gases in mind. CO is not the primary greenhouse gas. The primary greenhouse gases in Earth's atmosphere are water vapor, carbon dioxide, methane, nitrous oxide, and ozone. Now to the eighth question: what is the principle of Cottrell precipitator? Osmosis based on concentration of solute, neutralization of charge on the colloidal particles, acid-base neutralization reaction, reverse osmosis. So the answer is option B. Let's see the principle. So Cottrell precipitator is very high efficient filter device, and it is used to remove very fine particles like dust and smoke. And from where is it removed? It's removed from a flowing gas, and there is a use of force of an induced electrostatic charge. So there will be a flowing gas with a lot of particles, fine particles, and this will be moving across an induced electrostatic charge, and this in this stage there will be neutralization of the charges on the colloidal particles, and those settle down, and that is how the Cottrell precipitates work. So from the flowing gas, it will be flowing through a force of induced electrostatic charge, and these fine particles will be, which are colloidal, will be neutralized and they will settle down. And this is how The filtration takes place in Cottrell precipitator. This is very important term, Cottrell precipitators. For 12th standard students, you know this is really important for your surface chemistry chapter. So keep this in mind. So the ninth question here is, Wilson's disease is a genetic disorder caused by. So we have four elements given here. Answer is option C, copper. Wilson disease is a genetic disorder in which excess copper will be built up in the body, and all the symptoms are related to brain and liver. Again, Wilson disease, Minamata disease, all these are really important when we are considering environmental chemistry or even biochemistry. These names of these diseases and the chemical causing these disorders are very, very important. So copper causes the Wilson's disease, and it mainly affects the brain and liver. So what is used to treat acute and chronic lead poisoning by pulling toxin? Iodine pellet, carbon disulfide, EDTA, and calcium chromate. Again, a very topic-based question, but can be asked in all kinds of examination. So here the answer is option C, EDTA. What happens is, it's something called chelation therapy. And here, the treatment involves repeated intravenous. What is intravenous? Directly into the veins, injected directly into the veins. So, into the veins, administration of a solution of EDTA will be done in chelation therapy. And this is used to remove many of the heavy metals. EDTA, that is the intravenous administration of EDTA will be used to remove heavy metals like lead, cadmium, and mercury from the bloodstream. So acute and chronic lead poisoning can be done by pulling, the treatment for the acute and chronic lead poisoning can be done by pulling toxins using EDTA. So what is EDTA? It is ethylene diamine tetraacetic acid. Please understand what this compound is and what chelation therapy is and for what it is used. So chelation therapy, the administration of EDTA takes place and it is used to pull out toxins like lead, cadmium, and mercury. And it is also known as chelation therapy. Okay, these are the terms you should remember. Which of the following statements about photochemical smog is incorrect? So these are all very highly related sentences. One is, it has low concentration of oxidizing agents. It has high concentration of oxidizing agents. It can be controlled by controlling the release of NO2, hydrocarbons, ozone, etc. Plantation of some plants like pines help to reduce the photochemical smoke. So definitely we know that the answer will be either A or B, because both these are alike, and either it should be a low concentration or high concentration. So answer is option A. It has low concentration of oxidizing agent. It is wrong because it is having a really high concentration of oxidizing agent, and it can be controlled by controlling the release of NO2 and hydrocarbons, ozone, etc. because these are the primary and secondary pollutants present in photochemical smoke. We have already discussed it in the first few questions. So photochemical smoke, sometimes it is also called as oxidizing smoke, and it is having very high concentration of oxidizing agent. Ozone is a common oxidizing agent, and there is a reducing smog also, and it is having high concentration of sulfur dioxide, which is a reducing agent. So this is some related information. And how does this particular statement about the plantation becomes true? That can be understood from this statement, that is, certain plants like pinus, quercus, pyrus, etc. can metabolize nitrogen oxide, and therefore their plantation could help in reducing nitrogen oxide from the atmosphere. And what is this nitrogen oxide? It is a primary pollutant present in photochemical smoke. So planting trees which can metabolize the primary pollutant, the gases which are the primary pollutants, in turn helps in controlling the photochemical smog. So that is why the fourth statement is also true, and only option A is the incorrect statement. That is, it has a low concentration of oxidizing agent. It is a wrong statement. Which of the atmospheric layer protects us by burning up most meteors? So all these are the different layers of our atmosphere. The answer here is option C, mesosphere. And Mesosphere is actually 22 miles thick. There will be 22 miles of mesosphere, and what happens is the meteors we can always it can come through exosphere and thermosphere, which are the layers of atmosphere, and it can reach till mesosphere. But what happens in mesosphere, in mesosphere there will be enough gases to cause friction and create heat and thereby destroy the burn up the meteors. In exosphere and thermosphere they do not have much gas, and as a result they cannot cause the burning up of meteors. And mesosphere burns up, as we understood, mesosphere burns up most meteors and asteroids before they are able to reach Earth's surface. And other facts about mesosphere is it is the coldest atmospheric layer surrounding the Earth, and it can become so cold that it can freeze water vapor in its atmosphere into ice clouds. So you can imagine how cold it is. So mesosphere is the coldest atmospheric layer surrounding Earth, and it can burn up most meteors in there because it has enough gases, and the thickness is 35 kilometers or 22 miles. Now the 13th question is, which of the following statements is false? Again, this kind of questions can be repeated everywhere. Classical smoke is called reducing as it contains high concentrations of sulfur dioxide in nature. Sulfur dioxide, which is a reducing agent. London smoke is oxidizing in nature. Photochemical smoke creates eye irritation. London smoke is a mixture of smoke and fog. So some things are very clear from this. Option C and D are definitely true statements because photochemical smoke has PAN, which causes eye irritation. And smoke itself, the term itself makes us understand that it is a combination of smoke and fog. So we have narrowed down our answers to option A and B. So out of those, option B is the incorrect statement because London smoke contains sulfur dioxide again, and it also has carbon, and so it is reducing in nature, not oxidizing in nature. Just like the statement about classical smoke, even London smoke contains sulfur dioxide, which is a reducing agent, and therefore the smoke is reducing in nature and not oxidizing in nature. So option B is the incorrect statement. Now acid present in acid rain are H2CO3, HNO3, H2SO4 and HClO4. This is a multiple answer question. Both option B and D are correct. HNO3 and HClO4, both these are present in the acid rain. So acid rain is caused by the emission of nitrogen oxide and sulfur dioxide. These two, actually the option B and C are the correct answer, not D, sorry. Option B and C is the correct answer because HNO3 and H2SO4 are the major components of acid rain, because on emission of nitrogen oxide and sulfur dioxide, these two reactions, these two gases will be reacting with water in the atmosphere and oxygen in the air to form sulfuric acid and nitric acid. And you know, what is the relation between Taj Mahal and acid rain? We know the marble had turned yellow due to the acid rain, and we have learned about all those. I think I have asked one question from that part in the previous portion of the environmental chemistry question. So here the answer is option B and C. Emission of nitrogen oxide and sulfur dioxide. These two will be combining with water or oxygen to form water and oxygen to form the sulfuric acid and nitric acid, and these will be present in the acid rain. So the last question of today's part 2 of environmental chemistry question is about blue baby syndrome. So what causes the blue baby syndrome? It's option A, nitrites. So I don't know how many of you have heard about the blue baby syndrome. Most of the questions on environmental chemistry part has been repeated many times. So now the examiners will be looking for those areas from which questions have not been asked yet. One such area is this blue baby syndrome. So in the coming exams, you can surely expect one question from this part, because every time they won't repeat the question. As the time changes, questions also will be improved, and they'll try to explore areas from which questions have not been asked. Now let's take a look at what this blue baby syndrome is. So blue baby syndrome, it's also known as infant methemoglobinemia, and it is a condition where the baby's skin turns blue, and this occurs due to a decreased amount of hemoglobin in baby's blood. And we know that when we have lack of oxygen, our skin, our body turns blue, and that itself is the cause here. Because when water is contaminated with nitrates, and a baby drinks, or in after baby drinks formula made with nitrate rich water enters into the body, these nitrates will be converted into nitrites. And what is the speciality of the nitrites? So what happens? Nitrates to nitrites, then nitrites bind to hemoglobin, and this hemoglobin become methemoglobin, and this will be unable to carry oxygen. And what happens as a result? The body turns, or the skin turns blue. This is because of the lack of oxygen. Actually, hemoglobin will not be available since it reacts with nitrites to form methemoglobin. And now we know why the name methemoglobinemia. It is because of the formation of this particular chemical. Please write down this chemical name also: hemoglobin combining with nitrites to form methemoglobin, and thereby hemoglobin becoming unable to carry oxygen. So these are the 15 questions we are discussing today. We have tried to include questions that are less asked so far, and we see that these questions will be really important and will be asked in any of the coming examinations. Keep watching our channel. We'll be putting more videos and many general chemistry topics so that everyone will be benefited from these. And apart from that, the other entrance examination questions also will be done very soon. Thank you so much for watching our channel. Please like this video, share it with all your friends, and hit the bell icon for latest notification. Thank you. Take care, everyone.